Start you with off today is how you do what we call a system of equations. We're going to look at two equations and two unknowns. Okay. So first of all, whenever you have something like this is an example. The systems that you do are always going to have x and y or two variables in it, the same two unknowns. So an example, you'll usually see a system of equations written like this. Usually you'll have a brace. Then you might have something like 2x plus 3y, I'm just making something up, equals 10. X minus 5y equals 6. That's what systems of equations look like. And both of these things are linear. So what it means is, if you graphed those two equations, they would be lines. We're only going to look at the ones that are lines. And then the answer to that system is a point where they intersect. All right, so the first thing I want to show you is how you can tell if something's an answer to a system of equations. So this first thing I'm going to show you is pretty simple. I've given you, on example one, I've given you this system of equations. We're going to see if this is the solution or not. And then I'll show you a little bit here how you find this. So basically, x is 6, y is negative 4. All you got to do is plug that into both equations and see if it works in both. So I'm going to take the first equation, 9x, but I'm going to replace x with 6. Then I've got 13y, so replace the y with negative 4. And then we're going to see if that's equal to 2. Then we're going to plug it into the second equation. So that's negative 3 times 6 minus 5 times negative 4. We'll see if that's 2. So actually, you just plug into both equations, and it has to work in both in order for it to be a solution. Well, you work out the arithmetic. That would be 54 minus 52 equals 2. So that works. Okay, that checked in that equation. Then you got to do the next one, which would be negative 18 plus 20. And that's also equal to 2. So the answer to that would be yes. That's all you do. And it has to work in both. If it only works in one of them, then it's a no. Or if it doesn't work in either one. Okay, that's it. Okay, and then the next one's the same. Okay, x is 3. Y is 7, so you plug into the first equation. So that would be 3 plus 7 is 10. So that checks. Then if you plug it in the second one, you would have 3 minus 7 is 5. So that doesn't work. Okay, so this would not be a solution on that. All right, so that's all it is a solution. A point's a solution if it works in both equations. Everybody with me there? Okay, that's what a solution of a system is you now are working with two equations. And they have the same two unknowns. So what we'll do, what I want to kind of get through today is probably show you two techniques for doing these. The first one's graphing. So we've already learned how to graph lines. So we can solve these by graphing. And you can also do these on your calculator. I'll do a little bit of that on the calculator. All right, so what we're going to do is we're going to graph these two lines, okay? So the first thing is we have x plus y equals 7. And then we have negative 2x plus y equals 1. So the easiest way that I've taught you how to graph these is to solve these equations for y so that they're in the mx plus b form. Then we can find the slope and y-intercept and graph them, okay? So we've already done this. So what I'm going to do on this first equation is I'm just going to move the x to the other side, so I get y equals negative x plus 7, right? Okay, so just to review, what is the slope now that I've solved it for y? What is it? Negative 1. Okay, the slope is the number in front of x. Okay, and we're going to put that over 1 because we got to count out the rise over run. And what's the y-intercept? 7, right? Okay, so what we have is we have a y-intercept is the point 0.07. All right. So what you're going to do when you graph this, now that you've got that solved for y, you want to just start getting some dots here. So you put your first dot at 7. That's your y-intercept. How do you do a slope of negative 1 over 1? How does that go? Down 1, right 1. Down 1, right 1. Rise over run. So you want to just do that over and over again. Down 1, right 1. Just keep putting a bunch of dots. And when we do this problem, you need to just keep putting dots. Don't just draw a line, because that line needs to be accurate. So I would get as many points as I possibly can when I do that. So that's the graph of y equals negative x plus 7. Okay, so that's how that goes. All right. Okay, the next one, I think I wrote this down wrong, is negative 2x plus y equals 1. So when you graph it, solve for y. So what we're going to do is move this to the other side like we've learned. So that's y equals 2x plus 1. Okay. All right, what's the slope on this one? Okay, anybody there? 2. How do you do a slope of 2 over 1? How do you count it? Up to, right, 1. What's the y-intercept? 1. Okay, so your y-intercept is the point 0, 1. Okay? Now this is stuff you need to be totally on top of, because you do this all the time. Over and over again this semester, you'll be graphing lines. Okay, so I'm going to plot the point 0, 1. If I have a slope of 2 over 1, we're going to go up to right 1. Okay, from the point where you plotted. So just go up to right 1, up to right 1, up to right 1, just until you run out of room, and then just graph that, like that. Okay? So what happened is they intersected, and the answer to this problem is always going to be where they intersect. Okay, if you figure out that intersection point, then you have that. Okay, so your intersection's right here. It looks like the x value is 2, and it looks like the y value is 5. So what you do is you just write this as the point 2, 5 like that. That's the answer of the problem. Okay, so if they intersect somewhere, that's going to be the solution. Now, I want to show you this. You can tell you're right. Okay, and this is super important on this. All you got to do is plug it into both equations. You can do this in your head. 2 plus 5 is 7, right? In your head, that checks. Do the next one. Negative 2 times 2 is negative 4. Negative 4 plus 5 is 1. So it doesn't take very long to tell that you're right. It should work in both equations. It's the only possible answer to that problem is 2, 5, because that's the only place it's going to intersect. That's it. Okay? Is everybody okay with the graphs of the lines? That's what this requires, is that you can graph lines good. Okay? If you can do that, you won't have any trouble with this. Okay? Okay. Next thing. Let's go ahead and let's do this, and I'll let you do a couple of these. Okay, so what we're going to do is we have the first equation is 2x plus y equals 4. The second one is 2x plus y equals 6. So we're going to do the same thing. We're going to solve for y. We're going to graph both equations. Okay? So I'm going to move this to the other side to get y equals negative 2x plus 4. Okay? The slope is negative 2 over 1. The y-intercept is the point 0, 4. Okay, so solve for y, then locate the slope and y-intercept, and then graph. So we'll have a y-intercept that's up 4. If you have a slope of negative 2 over 1, what are you going to do? Down 2, right 1, down 2, right 1. So from that point, just go down 2, right 1. And I would just keep doing it until I run out of room. And then you can connect that into a line like that. So that's your first line. Okay. All right, we'll do the second one. Okay, second one, again, you basically do the same thing. You move the y to the x to the other side to get this. Okay, so this time the slope is negative 2 over 1. And this time the y-intercept is 0, 6. Okay, so what we're going to do is you're going to start with the y-intercept of 6. What happened on the slopes? They turned out to be the same. So from this point, you would still go down 2 over 1, down 2 over 1, and remember, you're looking for an intersection point. What do you think? Is this thing ever going to intersect? No, okay. I mean, if the slopes are the same, then it's impossible for them to intersect. They will never get closer together. So we call these lines parallel because they don't intersect. So that means since they don't intersect, that means that there's no solution. So we just say that there's no solution as a result. So a system of equations does not have to have a solution. This one's impossible. I want to see if this makes any sense to you guys. Notice on this, the left side's the same, right? So if you did 2 times a number plus y and got 4, it would be impossible to do 2 times the same number plus the same number and get 6. That's impossible. You can't find a number, x and y, that works in both of those equations at the same time. So that's why it has no solution. Okay? So what you're doing with this is graphing, looking for an intersection point. That's it. Okay, so I think let's go ahead and work out the next two yourself. I'll kind of come around and see if you're on track with these. You want to solve for y, then use that information to do your graphing. So I need to see that everybody's okay on how to do this. So then you're looking for an intersection. It could be parallel. It just kind of depends. But try to make sure you solve your equation for y okay. And then look for that intersection point if you have it. Most of you getting an intersection on the first one. That's what happens. I haven't done these yet, but that's what I'm seeing. Be careful when you solve the second one. The second one should be, I think, where you're going to come up with the intersection. Sometimes what students do wrong on these problems is the solving for y part kind of messes up a little bit. So let's see, I'm going to go ahead and put this first one up here and see. It looked like most all of you were getting one that intersects. So let's see, if you solve for y, you have y equals 4x plus 3. So your first graph, you would have a y-intercept of 3. And your slope would be 4 over 1, so you can go up 4, then over 1. Now you can do that backwards too. Up 4 over 1, you can go 1, 2, 3, 4 down and to the left. So if you can count one way, then you want to count the other way.
Isn't it negative?
Well, what I did is I moved that over the other side. So what I'm doing is I'm adding 4x to both sides. Okay, so that would be what your first line looks like, is like that. Okay, then your second line, you would have a y-intercept of -2. Your slope on this is -1 over 1. So you would go down 1, right 1, down 1, right 1, like that. So it looks to me like this intersects at -1, -1. Okay, if you got that, then you solved it correctly. How many people got it? Good. Okay. Okay. Let's do this next one real quick, and then we'll be done. Okay. So this one, I'm going to move the 6 to this side, and I'm going to divide by -3. Everything has to get divided by -3. So if you didn't get this, get this written down. So that would be 2x minus 1. So your first graph, you would have a y-intercept of -1. Slope would be 2 over 1, so you go up 2 over 1, like that. I'll kind of go like that. Right, the next one, I'm going to move the 2x to the other side, so I get negative y equals negative 2x plus 4. Then I can divide everything by negative 1. So you would get y equals positive 2x minus 4. Okay, so if you graphed the second one, which would be this, the only difference would be you'd have a y-intercept of negative 4. You would still get up 2 over 1, so what happens on this problem? Okay, they're parallel, so if you go through and graph those, they're parallel, so they don't have a solution. The thing that you got to watch on these problems is how you solve for y. You can't mess up on that, because if you do, it'll throw everything off. Okay? All right, so we'll wrap us up for today.